Morning. Welcome to today's lesson on patterns. Okay, this is a pretty simple little one. This actually should probably be short by comparison to most of my other videos. I just want to talk briefly about pattern recognition, and really why are we applying it? Why are we interested in it? Okay, because they come up a lot, actually more than you probably realize, and that's what I'm hoping to impart upon you today. Is we're looking at patterns. Okay. So let's just take a simple pattern, for example. I'm going to make a little box here. And in this box, we can see that if we were making it out of toothpicks, that there would be 4 toothpicks in this box. If we added another box to it, though, a lot of people think, oh, you must be adding 4 more toothpicks. But if you look, you can see that I actually only drew 3 more lines. So now this thing has 7 toothpicks. If I were to add a third one, it would go to 10. If I added a fourth one, it would go to 13. And you can see, hopefully you can see a pattern forming. Okay, obviously that's a pretty straightforward and simple pattern. But what do we use that for? Okay, we use this when we want to look at graphing. Okay, this is something we're going to be doing quite a bit of in our math careers, especially this year. But also when you look at, I gotta say, I think in the times that we're in right now, we've probably been overwhelmed with graphs and charts and bar graphs and God knows whatever else. You've probably seen hundreds, and maybe sometimes you don't quite grasp what they're conveying, because you look at the okay, it goes up. Maybe you just kind of go, well, it's going up, or hey, it's going down, or hey, it's going up and down. Now I don't know what to make of it. Or maybe it's just comparing who knows what. And you have to be very careful when it comes to statistics. You can find probably statistics that state almost anything you want if you're careful about it. Okay, that is something that always scares me a little, is that you can basically get a statistic to convey something that isn't even necessarily true, just it's the idea that you want. That's why you have to be very careful, and you have to be able to read them accurately. So again, we're going to be using this to evaluate graphing for the most part. Okay, but for right now, we're just in understanding patterns, okay? Because we use them as what we call a predictive model, okay? If we see, hey, the number of people who bought something in the store yesterday was 4, and then Tuesday is 7, and Wednesday is 10, and Thursday is 13, I would say it's safe for me to say I think tomorrow there'll be even more people. In fact, I have a very specific guess as to how many people will buy something in the store on the next day. Now, that doesn't mean that it's automatically going to be true. It just means that I have what's called a predictive model. I have a pattern that I have acknowledged and I have recognized that I think is going to continue. Now, let's put it in context of what we're dealing with right now, is how many people have the coronavirus. Okay, and you can use a predictive model to say, hey, look, if there were more cases yesterday than there were the day before, then there'll probably be more cases the day after that. So then you start having to look for, if you look back to our last lesson, factors. What factors contribute to more people having it? And then you try to control that. That's why patterns are so important for us to recognize. Okay, so now I want to talk to you about specifically just how we do this in math and why. Okay, this is going to lead to graphing. Okay, that is where we're going with this. For right now, we're going to acknowledge just the pattern, but I want to take it to the next level and show you the graphing. And the first thing I'm going to do is I'm going to make a table. And in that table, and I know it looks like I'm writing down like that, like at a slant. Yeah, it's going to be the fun of these little lessons. So in the top box, we're going to put the number of squares. Okay, that's our number of squares. That's each one of these. And then this bottom box is the toothpicks. So in the first, there's 1 box, and there are 4 toothpicks. In the second, there are 2 boxes, and we know there are 7 toothpicks, and so on. 3 is 10, and 4 is 13. What we have created here is a group of points that we are able to graph onto a coordinate plane. And we would list them as so. This is the point 14, this is the point 27, this is the point 310, and so on. That means we can now draw a line. This is called a linear equation, meaning the equation of a line. So I can take this and put it onto a graph like this, a T. Sometimes people refer to this as a T-graph. Okay, I just refer to it as a graph. There's nothing special about it. It has your X and it has your Y, and we'll talk a lot more about this in the future. This is, again, just to really drive home, why are we doing this? What is the application? Looking for patterns, that seems pretty banal, pretty easy, well, why am I bothering? Okay, but why is so we can get it to the point where we can put these points onto a graph. So 1, 4, and 2, 7, and 3, 10, and it should create a straight line. As badly as I can draw, it still did create a straight line. And this is one of the most simple patterns that we're going to deal with, and that's a straight line. But they're very valuable, and line graphs are probably the most common. You'll deal with them a lot because there are a lot of things that are going to happen linearly. They're going to happen the same way every day, all the time, all the time, all the time. And that is going to make something that you can actually predict, something that you can actually say, this is how this is going to play out, and therefore this is what's going to be the 10 down the line, 20 down the line. Okay, and that's what you're going to be asked to do in your homework. Is they're going to ask you, what's the next one? What's the one after that? What's the one after that? And then all the way down the line, they're going to say, well, what's 10? Okay, and then the other real important factor here, and there's only one more thing I'm going to talk about, and that is to describe it. If I said, how's it changing over time? Well, you find the difference here is 1. So the difference between the number of squares is 1. And the difference here is 3. Well, here's the weird part. You kind of flip it. So it's 3 over 1. So it becomes, it's going up. So it's, in this case, you could say it is adding 3 every time. Okay. Now, we're going to use this a little bit later on to write our own equations. That's going to be a whole new level of difficulty. But we'll be able to do it because we understand how this works. Okay, so if it's going up by 3 every time, that means that this number, which was our x, is times 3. And this number, our y, was something that it equaled. And then there's that weird little, well, if it was just times 3, it'd be 3, 6, 9, but it's not, it's 4, 6. So what would I need to go, if I had 3 times 1, but to get to 4, what do I need to do differently? I need to add 1. Okay, that's a little advanced. So if that's not 100% clear to you right this second, don't worry. It will become clear later. Okay, for right now, we're focusing on recognizing the patterns, predicting the patterns, and describing the patterns. Tell me what is happening. What's the change? Is it adding? Is it subtracting? Is it multiplying? Is it dividing? Okay, these are all things that it can be doing, right? We have 4 major operations. I mean, eventually you'll even see exponential changes where things can go an exponent. It would be to the second power, to the third power, and so on. That's the thing that's the scariest, things that have exponential growth. Okay, but that's what we're going to be looking at. Again, recognizing patterns, identifying patterns, and naming patterns. All right? Okay, see you next time.